Alright, so this is me doing Minecraft and doing a voiceover with supposedly a better microphone. Whoops. Sorry about the audio bubble there. Yeah, look, I have no idea what I did in this episode, but I recorded it and then I realised that the audio was completely rubbish. So, yeah, you couldn't hear what I was doing and couldn't hear the wonderful dulcet sounds of Minecraftia. So, to fill out this audio space and to add some decent texture to it, let's start with somebody once told me the world is going to roll me. Ain't the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape of an L on her forehead. Well, the years start coming and they don't stop coming. Fed to the rules and I hit the ground running. This is a bad one. Anyhow, don't make sense not to live for fun. Your brains get smart, but your head gets dumb. Good philosophy there, I suppose. So much to do, so much to see. What's wrong with taking the back streets? You'll never know if you don't go. You'll never shine if you don't glow. Hey, now. You're an all-star. Get your game on, go play. Hey now, you're a rock star. Get the show on, get paid. All that glitters is gold. Only shooting stars break the mold. It's cool, a cool place. And they say it's getting colder. You're bundled up now, wait till you get older. But the meteor men beg to differ, judging by the hole in the satellite picture. Ice we skate is getting pretty thin. Water's getting warm, so you might as well swim. World's on fire, how about yours? That's the way I like it, and I never get bored. Hey now, you're an all-star, etc., 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 blah, 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 blah. Yeah, great, this is super exciting. I'm getting bored with this. Something about going for the moon, blah, blah, blah. And the All-Star was a good song when I heard it back in the dark ages. Oh, this is the point where I found clay. So exciting. Yeah, Minecraft does that, doesn't it? But, you know, these days I go, oh, it's thoroughly memed, and Shrek, well, the first one was funny. Oh, I probably can't say that, can I? Complaining about Shrek and the quality of Shrekisms. But anyhow, where was I? Oh, yeah, more about All-Stars. Hey now, you're an all-star, get your game on, go play. Hey now, you're a rock star, get the show on, get paid. All that glitters is golden, only shooting stars break the mold. Somebody once asked, could I spare some change for gas? I need to get myself away from this place. I said, yep, what a concept. I could use a little fuel myself. And we could all use a little change. Oh, that's the point where the audio wiped out for others. Oh, yeah, sorry, got distracted. But hopefully the levels and all that sort of stuff will be right from this point onwards. This track didn't have any audio initially from Minecraft, but, you know, given the sound of that storm, I'm surprised people are even tolerating to put up with that. And that's about as far through All-Star as I can be bothered going at this point. Alright, sorry, big blast there. And then I've still got like a whole 5 minutes to go of this, and really, it does my head in. Totally does my head in. So, what else can I rabbit on about? Oh yeah, I was talking about number systems back in the next episode. And one of the cool things about number systems is the second form of they get stored. So the first time I talked about integers, that was the word. And, you know, basically whole numbers and that sort of stuff and how it gets stored in a computer. And that's pretty simple. But things get interesting when you deal with floating point numbers. Then these are like massive numbers. So, you know, in dealing with an integer, the biggest integer you could store was how many bits you gave over to it, to the power of the number of bits. So an 8-bit integer was 256 or 255 because it starts from 0 and goes up. And then, I think a 16-bit integer was about 65,000, a bit higher. And then a 32-bit integer was about 16 million. And it just gets bigger and bigger than that. These numbers will be completely out because I'm running off memory here and my memory is wonderfully faulty. But when you look at what they can offer, to store a massive number becomes impossible. So what do they come up with? They come up with this thing of basically using scientific notation. So those of you who happen to have done a science and know how to do this in maths, it's pretty simple. It's broken into two parts. You have the numbers out the front, and then you have how big that number is, which is, 10 to the power of something. So, the bigger the number that gets, the bigger the power, the bigger the number gets, or how many digits it has. No, not digits. That's the wrong word. How far the decimal place is shifted across. So if you take, say, 2 times 10 to the power of 7, that will be about 70 million? Yes, 70 million. 20 million, not 70, because it's got basically 7 zeros on the end of it, and it starts with a 2. The number gets broken up into two parts. The first is the mantissa. I've never heard this word anywhere except computing. It's one of those oddities. But what it gives us is basically the digits out the front, starting from just on the left side of the decimal place and going from there. And and then we have the exponent, i.e. whatever it is, 10 to the power of the exponent. So how big that thing ends up being. Oh wow, it's so exciting. I'm making stone. Oh yeah, I was going to do a couple of picks, a couple of digging utensils to get through this mess of stuff. And lo and behold, I forgot. So yeah, back onto the number systems. The two combine together. And although they're not like completely accurate and unflawed, like in that sense, what happens is you get the ability to store massive numbers without using up too much space. So it's a useful concept and that sort of stuff in terms of computing and making things happen. And that's the second of the two things on number systems I actually wanted to talk about. There is more ways of storing data. The simplest is what's called a bit. It gives you a yes or no value, and it's used for storing booleans, true or false, which, I think a 1 is false and a 0 is true, or maybe it's the other way around. I can never remember. But dealing with this level of computing, unless you're going into the nuts and bolts and doing something very particular, then you can double check it. But all in all, it's not really critically important. And the other form is actually storing characters. So any piece of text. And the old text standard was, of course, ASCII. And I can probably talk about that later and just let Minecraft play itself out, because I've got no idea what's going on. And sorry for the background noise, but there's a television. And that's, two of the major types of... three, because you got booleans, integers, and floating point numbers. And they're used to do all those sorts of calculations in computing. The ASCII stuff, or the storing of text, that comes later. But, it's pretty naff in terms of what it is. And I think I'm done for this evening. This is the episode 2 catch-up, because the audio was rather bad. The other thing you can also think about is... what the hell do you want next? Should I bother upgrading to the new version of Minecraft away from 1.0 to 1.1? That'll be trivially exciting. And I think we're done.